Okay, so today what we're going to do is, guys, we're going to begin our next things, which is tables, equations, and graphs. Okay? Yes, it is an external. Who knew that they wrote it right on the front of the book? Now, and the first thing we're going to look at is we're going to be looking at some patterns and some basic information about graphing. And the title of this section is Straight Lines, which can be a little misleading because we're talking about things that would make a straight line, but not all of these graphs will be a straight line. Can things line up in a straight line and not be touching?
Yes.
Absolutely. And so keep that in mind as we go. That's probably the biggest point of this particular lesson. All right. So the first thing we want to talk about is just kind of revise our knowledge of what's called the rectangular coordinate system, right? Your basic algebraic graph. Two-dimensional, right. We have two number lines.
Do we have to draw this?
You can draw it. It wouldn't hurt you. We have what's called the x-axis, and that's the one that's flat or horizontal, right? And it's going from right to left, and the numbers, as you go to the right, get bigger. And if you're on the left-hand side of the other line, they get smaller. And to indicate that they're on the left of 0 and they're getting smaller, we put the little minuses in front, right? So it's just a number line. Then we have a second number line, which is called the y-axis. And as you go up, the numbers get bigger. What happens, do you think, when you go down? They get smaller. And to indicate they get smaller, we put the little minuses in front of them. Now, I've gone in a scale of 1, 2, 3, 4, so 1 unit. Do they always have to do 1 unit at a time? Nope. It could be 5s, 10s, 20s. You can use any units you want. The one thing you must remember, though, is that if I do 1s along the x-axis, I have to do 1s on both sides of the x-axis. But then I could do the y-axis in 5, 10, 15, 20. I could count in 5s. The only thing is that you must be consistent along the axes. And axes is simply the plural of axis. So you have two axes. X. So which one is the horizontal?
X.
And the vertical is y. Good. Now, if we have two axes, then that tells us that everything that we put on this graph has to have two values. These things are called coordinates, which is where the system gets its name, the rectangular coordinate system. Okay? And it consists of an x value and a y value. Hence, x and y, right? Where the x value always comes first, and it tells you how far to move either right or what? Or left, exactly. Right if it's positive, left if it's what?
Negative.
Negative, excellent. The y value tells you how far you're either going to go what? Up or down, excellent. Up if it's positive, down if it's negative, okay? Now, let's talk about how to plot a point, okay? First of all, you're going to start at the origin. And we haven't defined origin yet, but hold on a minute and I will. Write that down. Start at the origin. The origin is the point where where the number lines cross. So that's the point right here where both of the number lines cross, and they cross where they both equal 0. Both of the number lines would equal 0 at that point. So that's where you're always going to start your graphing. Then you're always going to do your x value first. And remember, your x value tells you how far you move from either right or what? Left. Okay? Then, from that point, don't go back to the origin, but from wherever you land, from that point, then you're going to use your y value. to tell you how to go up or down. Then make a dot wherever you land. Now think about this like you're traveling along the streets. If I tell you, if you're somewhere where the streets are square, clearly not Wellington, but if I tell you to go north 3 blocks and then east 2 blocks, you wouldn't go north 3 blocks, then come back to where you started and then go east, would you? You would go north 3 blocks, turn, and then do the east part, right? And that is the number one mistake made on these, other than signs going in the wrong direction, but is to make 2 dots for one ordered pair, one coordinate. It's one coordinate gets you 1 dot. So if I gave you the ordered pair 1, 4, we know it's an ordered pair. Look at the format of it. It's 2 numbers enclosed in what? Brackets with what separating them? A comma. Nothing else comes in that format but an ordered pair or a set of coordinates. Nothing. So you know you're graphing when you see those. Okay? All right. So where do I begin? In the middle, which is the point called the what? Origin. And my x value here is what number?
1.
Positive 1. So that means go to the right, how many? 1 unit. Okay? And from that point, then I can go count my y. What is my y value?
4.
Positive 4. You're going to want to get used to saying positive and negative because that'll tell you the direction. Which means go where? Up 4. And so that is my coordinate. And if you're just plotting points, you must label them with their name. And the name of it is the coordinates in themselves. So that is the point 1, 4. So if you can count, you can do this. Right? So if you'll notice they give you a bunch of points to use. And so we're just going to go through a few of them together. And again, I can't project this, so you're just going to have to follow me along with the thing. So first of all, always first notice what kind of units they're using. This page on page 6. Okay? Always notice what kind of units they're using. If you look across the x-axis, they have no number except for 10 and negative 10. But if you count those little lines between, you notice that how many lines do you count before you get to the 10? Right? It's in giving you units of ones. They just didn't write them all, right? So each line represents 1. So 1, 2, 3, 4, 5, 6, right? And on the left, of course, it's just the same but negative. Then they did the same. If you count up to that 10, 1 line is 1 unit. So they're doing 1, 2, 3, 4, 5, but you don't have to put every one of those numbers on there on the scale to indicate that. So what they want us to do, so they found point A. So find the A, and they're doing it backwards, right? So just start at the origin and then count until you get to A. You would have to go to the right, how many? How many units? How many of those little lines? 3. It's not on my thing. It's on page 6 of your book. No, first A. A. So you'd have to go to the right 3 and then up what? Right 3 and up 4 is the point what? 3, 4.
And do we write that?
It's already written. That one's already done for you. Okay? I was just doing the one there. So let's look at, I don't care. Let's look at point G, just for fun. Find point G. Notice it's down there, down near the bottom of the graph. To get there, starting at the origin, I need to go to the right, how many? 5. And then down how many? 10. So that is the point. Oh, so it's to the right 5 is?
Oh, to the right.
Yeah, to the right 5 is what?
Oh, yeah.
Positive 5. But down 10 is what? Negative 10. So that's the point 5, negative 10. Are you seeing it? Okay. How about point P? Where's P? It's right in the center, right? Do you go right any? No. Do you go left any?
No.
So that's the point 0, 0, also known as the origin. There you go. So the origin has values as well. Let's just do one more because you're going to fill out the rest of the chart for your homework. Ha ha ha. So how about E? Where's E?
Oh,
it's on the left hand bottom corner.
Exactly. So from the origin, we have to go what? 1, 2, 3, 4, 5, 6, 7 to the left,
-7.
which is -7. Good. And then down what?
-3.
Down 3, so that's -3. So the signs tell you which direction to move. The number tells you how many units to move. And if you'll notice, there's always a pattern for every one of the squares. These regions are named. This is region 1. Okay. This one is 2. This one is 3. This one is 4. Did I just do that backwards? Doesn't really matter. I don't think they'll ever ask for that. But if you'll notice, the signs will teach you. If you're positive and positive, the only place you can land is right here. Yeah, I think it goes the other way around. 2, 3, 4. That's it. Sorry. It goes counterclockwise for some reason.
What is this for?
It was invented in some crazy Frenchman, René Descartes. So he went backwards.
Right, for the 001.
Right, any of these, it's always, there's region 1, region 2, region 3, region 4. Again, I haven't, well, it's not going to kill you. You might be asked to say the signs of in a particular region, and later, if you move to calculus, then you'll definitely need to know this. All right? To be over here, we have to go left, and then what? Left and up. So that's a negative, then a positive would put you in that region. To be down here, I need to go what?
Negative.
Yeah, left and down. So negative, negative. Excellent. Okay? To be over here in this region, I have to go what? To the right and then down. So that's a positive and a negative. Okay? All right? So if you see the signs of your numbers, you know which one of those areas it's going to land in. So if you put it in a wrong spot, then you're going to, it's just a little way of checking. Okay? All right. The next thing, they want you to just plot some of them. You can just plot a few of those. I'm just going to call them out, and you're going to tell me right or left, up and down. So look at E. E is positive 7, negative 3. So what does that say to do? Right, how many? 7, and then what? Down 3. So what? That would put you in 4, right? Down here. Positive and negative. Okay? That was E on page 6, down to the bottom ones. All right, how about L? Negative 8 means go where? Left. How many? 8. And then what? Negative 3 is? Down. How many? 3. Right? Negative, negative means left and then down. Is good? Okay. So you're going to have to put some points on a graph. Now, I do want to talk about when you are plotting these points on a graph, okay? The tendency is if you have, sorry, my pencil keeps dying on me. Hold on. Okay, so we need to talk about continuous versus discrete data. It's data. Okay. Continuous. That means it can be any number. Okay? So examples of things that are continuous.
Money?
Pardon?
Money?
Money? You can have any amount of money, couldn't you?
Yes.
So you can have between $1 and $2. You can have cents, right? Okay? How about things like how much things weigh?
Yes.
Infinite number, infinite variety, right? Anything that you can have a fraction or a decimal of, right? So continuous means you can have parts. So you can have any fraction. It can be positive, it can be negative, it can be any value at all. Okay? Now, sometimes they're only positive, but that doesn't really matter. But all right. Now, discrete, however, means that you can't have parts. So give me some examples of things that you would not take parts of. A human being, people, exactly. Okay? So what else?
If you're measuring the amount of flowers in your garden.
Okay. Yeah, so each flower, right, has to be its own thing. If you took it all apart, then it wouldn't be a flower anymore. Okay, I'll go for that one. Think about things in this room.
Pencils.
A pencil? Can you have half a pencil?
Kind of.
Yeah.
But it's still
Yeah,
just one.
it's still just one pencil, really, in reality, right? Even no matter how big or small it is. Now, what if you were measuring the lengths of pencils?
Different. That's mil.
The lengths of pencils would be continuous, but the number of pencils would be discrete. Okay?
Cheers.
Okay? So you get the idea? So usually it's properties of items that can be continuous, but individual items. So if you look at their example, they're talking about buttons, buying buttons. Would buttons be discrete or continuous? Discrete. You can't have part of a button that would be worthless, right? Okay? So you can see that there are different types of data. Good job. Okay? The next thing we want to talk about is something called linear patterns. And if you've been in year 7 or year 8 or year 9 or year 10, then you've seen linear patterns before. Now, it doesn't necessarily mean that you know how to find a linear pattern or remember it, but it's all right. For linear patterns, there's a formula. Now, the formula that you would typically use for linear patterns, we're going to use later for something. We're going to replace the numbers later. But for right now, I'm just going to go ahead and use the same ones that you would use for any regular linear pattern. No, they're not. All right. Which is T, which is the term, okay, equals A, which just means any number, right? N, and what does it mean if you have A and N crammed together like that? Multiplication times. Good. Plus B. Okay? Now, yes.
A equals any number times the other. Wait, what's N?
N is the number of the term. Okay? Where T is the value, hold on guys, of the term. Give me a minute and I'll explain each piece. N is the number of the term.
So A is any number.
Hold on a minute. Yes, and A is any number and B is any number. And it can be plus or minus. And we're going to talk about how to get it. So you know it's an N if it's, oh, sorry. I can't write. You know it's an N if it says first, second, third, or something like that. The value, T values are going to be just like 5, 24, -7, who cares? Whatever number you get, right? When you put it into the pattern. So T is what you get when you put your N into the machine, into the rule. Okay? So what we're going to do is we're going to learn how to write.
Wait, we're not just going to define this.
What am I going to define? A and B are any number. And we're going to learn how to find them. A and B are just numbers. We don't know what they are. But T and N have specific values. Okay? To write a linear rule from a pattern. You bet. Somebody remembers. We're going to use common differences. Okay? First, find the common difference, which I am hereafter going to define as CD, capital CD. So if I write capital CD in there in directions from this point forward, you know that means common difference. Common difference, okay?
That's what I said.
There you go. That's what she said. I knew it. And to do that, all you need to do is you're going to look at your not your ends, but they call it, and they're giving them names. So we're talking about buttons. So they don't use T for term; they use B for buttons. So if you're talking about cats, they would use C for cat. So they're giving the names definite names. You don't have to. You can always use T if you want to for now. Later, you're going to find that it changes when we start graphing, because we're going to have an X value and a what? And a Y value. Okay? All right. Come on, guys. Focus with me. Just got a little bit to do. All right? Your first step, subtract your second T. Okay, wait a minute. Sorry. Subtract the first T from the second T. And it's really important that you do it in that order, because if you don't, you're going to get the wrong sign, because it needs to either be plus or minus. Okay? Now, in order to check these, we also then need to subtract the second T from the third T. Okay? I'll show you. Hold on. Just chill for a minute. Okay? We'll do the directions, then we'll do an example if you'll give me time. All right. This gives us our common difference, as long as those numbers are the same. If they're not the same, then it's not a linear pattern, or you have some issues with subtraction. One or the other. Okay? So go back and check your arithmetic. But if you find out that they're still not the same, then the pattern is not linear, so you don't care. Okay? All right? Now, so you could subtract them and get a 2, then a 2. Is that a good thing?
Yeah.
Yep, that means our common difference is simply 2. Okay. Second. Okay? Okay. This common difference is A. And where is our A? Okay. So this common difference is our A. And where do we put A? In front of the N. You got, there you go. Okay.
Do we do quadratics in this?
Yes. Okay. Ready? Step 3. Okay. All right. So now what we need to do is we need to find our B. And B is really easy to find. Okay, guys, focusing. B is easy to find by simply doing this. If A is positive, subtract it from your first T. And that will give you your B. Okay. All right, I'm going to write it down here. It's going to be a little crowded. If A is negative, what do you think you need to do? Add it. Good. To the first T to get your B. You do the opposite. So because it's already accounted for, what we're doing is getting rid of it, kind of. So you're going to add it if it's negative, subtract it if it's positive. Do the opposite. And that will give you your linear rule every single time, as long as it, again, is linear. Okay? So usually this is given to you in the form of a chart. So I'm just going to write out a pattern. Not even going to use one. We'll use one from the book, what the heck. So that way you can make sure you can do it. So look at number 1 on page 8 there. Okay? We want to write the equation. Now they didn't use T, they used B because they're talking about what? Buttons, right. But it's the same exact pattern. So look at your chart. Ready? I'm going to flip the page. Hold on, I can come back to it, and there's always a recording. All right, so here we go. We have a chart. Whoa, that's bad. Okay? We have our N, and we have, they're using B, but it doesn't really matter. 1, 2, 3, 4, 5, 6. Okay, let me write those further apart.
Yeah.
Thank you. You're funny. 1, 2, 3, 4, 5, 6. Right? Okay. And then they'd give you B as 5, then a 9, then a 13. So we need to do B is equal to AN plus or minus little b, or you could put that as T always. It doesn't really matter. They're using a B again because it's buttons. So the first thing I need to do is find out what A is. And A is that common difference, right? So 9 minus 5 gives me what? 13 minus 9 gives me what?
4.
So my common difference is 4. That always goes right in front of the what? N. Okay? T is going to stay T because we're never going to know how many buttons. That's part of the rule. So T and N stay T and N, but we're going to replace A and B. Okay? Now, I need plus and minus B. So since my 4 is positive, I'm going to take the first value, which is what in this case? 5, and add or subtract 4? Subtract. You do the opposite, which gives me what?
1.
So, and what kind of 1 is it? So plus 1. How easy is that?
So easy.
It doesn't matter.
I get the same answer.
I'm fine with that. I'm just giving you a possible way to do it. I think it's easiest way for me, and that's the way I did it. But if you learned it another way, it makes no difference to me, right? As long as you ended up with this, I'm never going to say your method's wrong. Okay? All right. Perfect. How happy are you? Okay. Now, since we have the chart and we know the difference is 4, do I need to plug 4, then 5, then 6, then 7, or whatever into that to get the rest of these values in this chart? No, we can just add 4. What's the next one going to be? 17, 21, 25. But what if I wanted the 100th value? Do I want to keep on adding 4 or 100 times? No. So the 100th value, 100th with a TH, means that's a T or an N?
N. 4 times. It's the 4 times the number.
We can tell that it's 100th value. That's a number. That's an N. Okay? So we'll just use substitution. T equals 4 times 100 plus 1. T equals 400 plus 1. So T equals 401.
Yeah, but that's fine.
And you can do that with any number, right? So what if I wanted the 1,000th number? I just plug in N equals 1,000. Okay? All right. And then they want you to plot those points on the line. So, on the Cartesian plane there, on the rectangular coordinate system. First of all, if you look at it, it's got your X and your Y, but they call it N and B, right? N the numbers, so which is the first one. N goes along horizontally. B is, but what do you notice there? It starts at 0, 0, then it goes 1, 2, 3, 4, 5, 6, 7, 8 to 20 in one direction. Goes to 20 in the top up. What does it not do? Doesn't go down or what?
Right.
No.
Does it go to
You're either right.
Sorry, I thought.
Why not?
Because there's no negatives.
You can't have a negative number of buttons, can you?
Yeah.
So some graphs will not include every single quadrant. Okay? All right. Are we good?
Do we have to plot it in? Do we plot it in?
So yes, you'll put it, so like you're doing the first one, it's over 1 and then what? To the right 1 and then up 5. So you have to plot all of those values. So the first one, you have to fill out the chart, and then you have to plot those values on the graph. Okay? All right. How's it look? Can you do it? So your homework. Oh, homework. Pages 6 through 10. Okay? Now, guys, you need to get this done before we meet again, if at all possible. At least have done a couple of them, because we're going to build on what these ideas. So if you don't have this idea, you can't build on it. So at least do a few of them to know that you're doing it right. Okay?